equations. Let me abbreviate a little bit here. One comment, if some of this material is a little bit confusing or you need some more detail on it, there are 2 other sessions you may want to see first, or certainly after this. One would be finding the other trig solution. That's one session. And another session could be expressing infinite solutions for trig functions. Both of them, I'm sorry, for trig equations. Both of these are available and could supplement this session. All right, so first of all, how do we recognize what is a basic trig equation? So, if we have sine of theta equal to 0.7, it's understood that the coefficient here in front of the trig function is 1, and the coefficient in front of the angle is 1, and then you just have the trig function equal to a number. That is a basic trig function, or trig equation. Another example, cosine of an angle equal to negative 0.3. Again, coefficient of 1 in front of the trig function, a coefficient of 1 in front of the angle, and it's just equal to a number. So that is what the type of equation we're going to be solving. Now, process for solving. Is going to be 3-step. First one is going to be find the calculator solution. Alright, and that I abbreviate by putting CALC, calc, next to it. The second step would be find the other solution, and I'll use other next to it when I go ahead and label it. And finally, find infinite solutions. Okay, so these are the 3 steps that I'll be using, and I'll go ahead and apply it to the 2 examples we have above. So in the first example, sine of theta equals 0.7. Now, theoretically, we would take the inverse sine of both sides, and then theta is the inverse sine of 0.7. And technically, the question you're asking the calculator to give you is the answer to this question. For what angle theta in the interval negative pi over 2 to pi over 2 is the y-coordinate 0.7. That's what you're asking the calculator to give you. Because remember, theoretically, the calculator is restricted to that interval for sine. So it can only look there. So what it'll give you, it'll say theta is 0.7757. Now, what this means is, on a unit circle, that here somewhere where you rotate 0.7757, that the calculator gave you, this length here is y equals 0.7. So that's what's understood. And by the way, when I do use the calculator, I'm always in radian mode when I'm solving trig equations. You don't want to be mixing up angles and radians when you're solving complex trig equations. So that'll give us that gave us our first solution. Now we want to look for the other solution. Now, again, you have to keep in mind the question you're looking for is for what angle or angles is the y-coordinate a length of 0.7. So the calculator gave you 1, it was restricted, but you're not restricted, and you can look other places. So if you look on the circle, if this is 0.7, so is this over here in quadrant 2. This is also a length of 0.7. So you want to know what is this angle over here, this rotation. So this is the other solution that we're looking for. This was the calculator solution that you were given. Now, to actually find out what this other solution is, remember that essentially, if this is 0.7757, then that means this is also 0.7757. So if I want to know then what is this right here, I can think of it as over here pi and then back up 0.7757. So to actually find this here, this other solution, I would do pi minus 0.7757, which would give me 2.3659. This is my other solution. Okay? Now, that ends right there. To find the infinite solutions, since these solutions are not equidistant, I would just say theta equals 0.7757 plus 2k pi, and theta equals 2.3659 plus 2k pi. And that's it for the first example. Let's move on to the second example. So that's cosine of an angle, theta, is equal to negative 0.3. So again, theoretically, you take the inverse cosine of both sides. So you're looking for the inverse cosine of negative 0.3. Now, when you are looking for the calculator solution, again, remember what you're asking for. You're saying, for what angle in the interval 0 to pi is the x-coordinate negative 0.3. Okay? So where is it that x is negative 0.3? Well, it's somewhere here. Right? There's x being negative 0.3. And the calculator between 0 and pi is going to give you this solution right here. Okay? And when you put that in there, you get 1.8755. That's the calculator solution. And then we move on to what is the other solution. So, where else on the circle is it that the x-coordinate is negative 0.3 over here? Well, we found one of them was here. The other one's going to be over here. So if the calculator gave me 1.8755 radians, and that was this rotation here, now I want to say, what is this rotation here? And that's basically just negative 1.8755. That's the calculator. That's the other solution. Sorry. The other solution is negative 1.8755. Some people like to have that as 2 pi minus that. So though it could be called negative 1.8755, another coterminal angle would be just to add 2 pi. And the thought on that visually is that you go 2 pi and then back up 1.8755. So you'll be here. That would be 2 pi minus 1.8755. And that would give you 4.4077. So whichever way you call it is fine. They're really just coterminal, so it doesn't matter. And so your infinite solutions are theta equal to 1.8755 plus 2k pi, and theta equal to negative 1.8755 plus 2k pi, or you could call it 4.4077 plus 2k pi. And that ends our session. Thank you for listening.